Hello, my name is Rob Patak from grade 11, and today I'm going to be guiding you through the process of how a mass spectrometer works and what the process of mass spectroscopy or spectrometry is. So, a mass spectrometer is a device used to help us calculate the different isotopes as well as the relative atomic mass of a certain element. So, for example, if we have carbon, we know that its relative atomic mass is 12.01, and it has different isotopes such as carbon 12, carbon 13, carbon 14. And so using a mass spectrometer, we would be able to identify both of these. So I have prepared a model to guide you through the process of mass spectrometry. Now here we have our model of our mass spectrometer. So at the start over here, we see this inlet, which is used to place the element represented by the cardboard chips inside of the mass spectrometer. Then once it is placed over here, first it is heated by this heating filament, and the heating causes it to vaporize. And once it's vaporized, it is then bombarded with electrons by this electron beam. And what this does is it knocks off some of the electrons in the atoms of this element. When, due to this, it becomes positively charged. Now, we have these two negatively charged plates, and what they do, since they are negative, they will attract these positive ions towards them, causing the atoms or the element to increase its speed down this tube. Now, as we state, they're both attracted. They both attract the element, so it goes down this tube, and over here we have magnets, one positive end, one negative end, obviously creating a magnetic field over here. And what this does is, since these are now positively charged, the element will interact with the magnetic field created by these two magnets, and that will cause it to bend its path. Now, depending on the mass, it will either bend less or bend more. So the more mass the element has, or the certain isotope of the element has, it will not deteriorate from its path as much as represented by this lower line. And then the less mass it has, the more it will be deflected. So as you can see, this line here, since it has not deteriorated that much from its path, it clearly has more mass than these two beams, which have been deflected more. And then we come to the last part of the mass spectrometer, which is this detector. And what this does is it is able to pinpoint at which location these beams hit the plate. And using that, it is then displayed on a computer, and by reading those readings, we are able to determine what the different isotopes and the masses of the element are. That's how the mass spectrometer works. Now, after using the mass spectrometer, you will see a graph like this on your computer screen. On the x-axis, we see the mass of the different isotopes of the element, and then on the y-axis, we see the percentage of their relative abundance.